Okay, everybody. So this is going to be video 2, and so we're going to do the first third of the next 3 pages, so pages 4, 5, and 6. But if you're following along in the sequence, we're just kind of doing a problem or two off of every page, and then we're moving on, all right? So if you're looking at your review, let's talk about this first diagram. And so this is in the same vein as 2 lines cut by a transversal, but certainly it's a little bit different approach. And so if you notice, they're not saying, hey, these lines are parallel, tell me what the value is. They're giving you values, and they're trying to ask you if the lines can be justified to be called parallel. Now, the justification cannot be, oh, they look parallel. The justification has to be something with the angles and what the angle values are going to tell you. Okay? Now, the first thing we should establish, if we look at these angle values, they definitely are going to be in the corresponding position. Okay, so the first angle, which I'm going to call angle 1, just so we know which one I'm talking about, is to the right of the red transversal and above the line. Also, angle 2, which I'm not quite sure is going to be congruent yet, is also going to be to the right of the transversal and above the line. Okay? Now, we should also notice, because they're in this corresponding position, I'm sorry, not because they're in corresponding position, but because it was given to us, these angles are also congruent. Okay? And so now the question has to be, can we call the lines parallel at this point? Well, it turns out that we can, and the reason why has to be with the theorem itself. And so we've studied in depth something called the corresponding angles theorem, which says something which I'm going to kind of draw visually. And it says, if I have 2 parallel lines cut by a transversal, then what we can conclude is that the angles are going to be congruent. Okay? So if we have parallel lines, then we know angles are congruent. Well, it turns out, and it's maybe different than how like your teacher explained it in class, but it turns out this actually operates in both directions. Okay, so we typically call this the converse. Okay, and what this really says, I can go backwards. And so this says if I have, in this case, corresponding angles that are congruent, then I can say that the lines themselves are parallel. Okay, so this is not a really mind-blowing thing. What this means is that this relationship reciprocates. Okay, in other words, it doesn't just give in one direction; it gives in both directions. And so we can absolutely say that these 2 lines are parallel. And if we want to kind of say that within like the structure of geometry, we can kind of say like this: since the corresponding angles, in this case, angle 1 and angle 2. Are congruent, then the lines, line M and line N, have to be parallel. Okay? And this is exclusively the converse to the corresponding angles theorem. So the strength of this is that if you have lines that you know are parallel, that means you can set up some equations and determine values. But also, if you have angles that you know are congruent, that means you can tell me the lines are parallel. I know that's not a huge mind-blowing thing yet, but it's going to pay off so big in the next coming units. Right? Now, the other 2 problems are kind of this nature, but again, I told you from the very beginning, I just want to do about 1 problem per page and then move on. All right. So on this one, they're asking us to use a triangle sum theorem, but we probably could have guessed the triangle sum theorem was the thing that we wanted to use for 2 reasons. One, of course, we have triangles, right? But the second is the angles that we were given. We are told the interior angles of a triangle, namely that in this first example, we're given this one to be 56. We're given this interior angle, remember interior means on the inside, to be 51. And then we're told this top angle is 5K plus 3. Okay? By definition, the 3 angles that are the interior of a triangle are supplementary, meaning that we can add these 3 angles together. And that equals 180 degrees total. Okay? And so all we really have to do now is substitute into the equation. So 5K plus 3, 56, of course, 51. Okay. Just like any other problem, now that we know the triangle sim theorem informs our behavior, the behavior in this case, the equation, we can go about solving it. Probably cleaning up a little first, so 5K, we have 56, 51, and 3. So that'll give me a total of 110 degrees, which should, again, supplementary equal to 180. If we subtract off the 110s, we have 5K is going to be 70. Divide by 5s. K in this case is going to be equal to 70 divided by 5, which is 14. Okay. Now, we should check this. I told you from the beginning I had not actually worked these ahead of time. And we know 2 of the 3 angles. Let's find this third angle right here. Instead of 5K plus 3, we should have 5 times 14 plus 3. That's going to be 73 degrees. And so if I add that to the 51 and we add to the 56, 73 plus 51 plus 56. Whoa, that's not going to be good. Did I mess up somewhere? So 5 times 14 plus 3 plus 56 plus 51. Oh, there it goes, 180. I was just mistyping something. And so we have the 3 angles add to 180 degrees. We are good. Okay. Let's slide over and work the second example. Again, triangle sum theorem. We already established the rhythm of this problem. So we have the 3 interior angles again. Okay, so that means we can certainly add them together. To equal our supplementary total of 180 degrees. So that means we have 2x minus 5, 3x minus 17, x plus 40. Oops. And there's nothing special about me like skipping a space or anything to put them in a certain spot. I just want it to be color-coded so it makes sense to the diagram or the key if you're looking at it independently. But certainly we can kind of put the addition in any order we want. Anyway, we have 2x, x, and 3x. That's going to make, 6x. We have 40. Subtract off 17, and also subtract off 5. That's going to give us plus 18. Okay, so now we're in the algebra solving steps. So you're trying to get x by itself. Okay, so we have x to be 27. Now that number seems okay, but we should certainly check it. So let's substitute it back into our angles. Let's go top blue first. So 27 times 3 minus 17 gives us 64 degrees for our top angle. X plus 40, that'd be 27 plus 40, this guy right here, that's going to be 67. 2 times 27 minus 5, that'll give me this one to be 49 degrees. Now let's do one more check. Let's make sure they all add back to 180 degrees. Let's see if Mr. Collins can actually type in properly. They totally do, so I feel good about that problem. All right, let's slide down to this guy. All right, so again, this tells us we're going to use exterior angle theorem. But again, we could have guessed that simply because of the setup of the problem. We have one exterior angle, one angle on the outside, and then we have 2 interior angles, neither of which are adjacent or touching that exterior angle. So by the exterior angle theorem, what we can do is add the 2 interior angles together that do not touch the exterior, and that should be precisely equal to the exterior angle. In other words, if I take 4r, okay, and I add 66, I'll say I mix that up, no big deal, and that should be equal to 98. Okay, this little palette thing is driving me nuts. Now we're in the solving steps, so let's subtract 66. Okay, so I have 4r is the same as 98 minus 66. That'll give us 32. Divide out our 4s, gives our value of 8. Okay. Now going back to check, so we have 4 times 8 That'll give me this angle to be 32 degrees. 66 is given. And so to check a relationship, if I take 32 plus 66, that should equal our exterior angle of 98, and it sure does. Okay, same setup here. I have an interior angle. It's really thin, but I do have it. That's going to be 23. I have the other exterior angle, 5x minus 1. And when added together by the exterior angle theorem, it should equal our exterior angle, in this case 9x plus 2. Okay, so now we developed the relationship. It's about solving now. So 5x, let's see, that'd be plus 22 equals 9x plus 2. Let's do 2 steps at once here. Let's subtract off the 5x to move it to the right. And at the same time, let's subtract 2, moving it to the left. So we end up with 20 is the same as 4x's. So x is going to be the same as 5. So once we divide out the 4's, that's going to equal 5. That equal sign got out of control. Whatever. Let's move on. So let's now substitute back. Let's go green first. So if I take 9 times the x value, which is, of course, 5, add 2 to it, I end up with 47 degrees. Top one is given to be 23. To the right, we have 5 times 5 minus 1 for 24. Okay, so if I take that 24, add the 23 to it, I should get the exterior angle 47, and I totally do. Okay, so I'm going to stop this video here. So this is going to be kind of like pass 1, part 2. I'll see you guys in video 3.